Welcome to this presentation and overview of the Community Disaster Messenger Program. When disasters strike, one of the first systems to fail is often communications. Power outages, damaged cell towers, overloaded telephone networks, and internet disruptions can leave communities isolated at the very moment when messaging is needed most. That's where the Community Disaster Messenger Program and CDM Net play a vital role. This program combines emergency preparedness with the reliability of amateur radio, providing trained volunteers with a dependable method of communicating when conventional systems are unavailable. By serving as a communication link between the public and their loved ones, community disaster messengers help ensure that welfare messages can be sent from the disaster area by members of the public to their loved ones in unaffected areas when all else fails. Throughout this presentation, you'll learn how the program works, the role of the community disaster messenger, the basics of digital amateur radio communications, message handling procedures utilizing the CDM network, and how amateur radio volunteers can assist the public. Let's get started. So, what does it take to become a community disaster messenger? At its core, a community disaster messenger is a licensed amateur radio operator who is willing to dedicate their time, knowledge, and personal equipment to serve others during times of disaster. The primary mission is to provide welfare messaging for members of the public when normal methods of communication are unavailable. Being a community disaster messenger requires more than simply holding an amateur radio license. It begins with knowledge, understanding your equipment, knowing how to operate digital communication systems, and following established message handling procedures accurately and efficiently. It also requires training and practice. Like any emergency response activity, proficiency comes from regular training, participating in exercises, and staying familiar with the Community Disaster Messenger Network and operating procedures before a disaster occurs. Finally, it takes dedication. Community disaster messengers volunteer their time because they recognize the importance of helping people reconnect with family and loved ones during some of life's most difficult moments. Their commitment helps provide hope and reassurance when conventional communications have failed. Together, knowledge, training, practice, and dedication form the foundation of every successful community disaster messenger. To effectively serve as a community disaster messenger, volunteers should have the equipment and capabilities needed to operate independently when normal communications and commercial power are unavailable. First and foremost, every community disaster messenger must be an FCC-licensed amateur radio operator, holding at least a general class license. This is because a general class license provides the knowledge and legal authority to operate on the amateur radio frequencies used by the Community Disaster Messenger Network. Because long-distance communication is often required during disasters, each operator should possess HF amateur radio equipment capable of digital communications over regional and nationwide distances. A computer running either Windows or Linux is also required. In some cases, macOS is supported by the software as well, but it's limited to Silicon models. The computer supports the digital messaging software used to send and receive welfare traffic accurately and efficiently across the Community Disaster Messenger Network. Since commercial power may be unavailable for extended periods, operators should have a battery or solar backup power system. Maintaining communications during prolonged outages is one of the key strengths of amateur radio emergency communications. An NVIS, or Near Vertical Incidence Skywave Antenna, is another essential component. This specialized antenna provides reliable regional communications over several hundred miles, even when repeaters, cellular networks, and internet services are unavailable. Additional equipment is recommended to further improve communications capabilities. Starlink can provide internet connectivity when it is available, offering another path for message delivery. Portable NVIS and vertical antennas also increase deployment flexibility, allowing operators to quickly establish communications from shelters, emergency operation centers, or disaster sites. Together, these tools provide community disaster messengers with a resilient communications capability that remains operational when conventional systems have failed. One of the strengths of the CDM program is its ability to adapt to changing conditions through multiple modes of operation. Since no single communications method is perfect in every situation, the program employs several digital and voice technologies to ensure that welfare messages can continue to move, even under the most challenging circumstances. The primary mode of operation to move message traffic is through the WinLink email system, using the WinLink Express software client. Depending on the communications environment present, the WinLink system of email storage and delivery will normally operate through its network of common message servers, called the CMS system. When the Internet is present, this system can be accessed through the Internet directly using the Telnet system, and is usually the fastest method. When the Internet is not available or its use is not desired, RMS stations, or remote message servers, serve as the skywave gateways to access the CMS system in multiple locations around the country and around the world. A specialized type of RMS station is referred to as a hybrid RMS station. It is differentiated from a normal RMS gateway station by its unique ability to communicate with other hybrid RMS stations and forward message traffic in radio-only conditions or when the Internet is not available. MPS, or message pickup stations, are designated to receive, forward, and hold messages in a radio-only environment or when the Internet is not available. When setting up the WinLink Express software, each operator designates 3 MPS stations they will use in the Settings tab in advance of an emergency to ensure that their messages can arrive at those stations and be held for pickup at a later time by the recipient. Peer-to-peer operation involves direct station-to-station transmission of WinLink messages between 2 operators utilizing the software with no other system requirements, and standalone post office stations, or POs, can be accessed directly through the Internet or over the air, and act as repositories for messages which will be held for pickup at a later time by the designated recipient when conditions permit. A discussion of email message transmission over the air would not be complete without also describing the other requirements necessary for the successful movement of emails, files, and images over the amateur radio airwaves. And while WinLink Express is the software you most often interact with in the CDM network, it alone is not enough to affect email transmission over the air. It only provides the ability to graphically compose messages, read incoming mail, manage attachments, and choose which WinLink station you want to connect to. This is because WinLink Express cannot communicate directly over a radio. It needs another piece of software, or sometimes hardware, to translate those messages into signals the radio can transmit and receive. That's where a modem, or the TNC, comes in. The modem is software that acts like a digital translator. It converts the digital information from WinLink Express into audio tones that your radio can transmit. When receiving a transmission, It performs the reverse process, turning the radio's audio back into digital data that WinLink Express can understand. Some operators use a terminal node controller, commonly called a TNC. A TNC performs essentially the same function as a modem, but it's a dedicated hardware device instead of software running on your computer. Today, many operators prefer software modems or soft modems because they require no additional hardware beyond the computer and radio interface, while offering faster and more efficient communications. However, if only a soft modem is used, there must also be a wired pathway between the computer and the radio, which incorporates a sound card device in order to transmit the tones that the computer soft modem provides to the radio, and conversely, that which the radio provides to the computer modem. Some modern amateur radio models have sound card devices built into the radios themselves and do not require a separate piece of hardware. Only a direct USB cable connection is required. Older models normally do not, but there are several third-party manufacturers which provide equipment for this purpose. SignalLink and DigiRig are two such companies who provide sound card interfaces for legacy devices to transmit and receive digital signals. It is also important that an appropriately shielded interface cabling be used. This helps control and isolate the signals traveling between the radio and computer, which can reduce unwanted RF and electrical noise, prevent ground loop problems, and ensure that audio levels are appropriate for both devices. Many sound card interfaces can also control the radio's push-to-talk, or PTT function, so that the software can automatically switch the radio between receiving and transmitting, and also change the radio's operating frequency automatically when changed in the software user interface on the computer. With a proper sound card interface, amateur radio operators can use computer-based digital modes such as FT8, PSK31, RIDI, and other sound card-based communications effectively and seamlessly to send, receive, and process digital amateur radio signals. So, the communication chain looks like this. You create the email in WinLink Express. WinLink Express sends the data to either a software modem or a TNC. The modem or TNC converts that data into radio signals. Your radio transmits those signals to a WinLink gateway station, which delivers your email through the WinLink network. When receiving messages, the process simply works in reverse. Together, these components allow you to send email over amateur radio, even when the internet is unavailable. Additional primary communications tools include JS8 Call, which provides reliable digital messaging under weak signal conditions, and ComStat, which supports network coordination and operational awareness during a disaster response. Let's take a look at the features and operation of JS8 Call. JS8 Call is an open-source digital communications application built on the proven FT8 signal processing engine developed by Joe Taylor, K1JT. While FT8 was designed primarily for making quick contacts and exchanging signal reports, JS8 Call expands those capabilities by adding a messaging layer on top of the radio protocol. This allows operators to exchange normal text conversations while maintaining FT8's incredible weak signal performance. One of JS8 Call's biggest advantages is reliability. It is capable of decoding signals that are often too weak for voice communications. Because of this, JS8 Call has become popular among emergency communicators, preparedness groups, portable operators, and anyone who wants dependable communications during poor propagation conditions. Many operators successfully communicate hundreds or even thousands of miles using relatively low power. The software operates much like FT8. The computer generates digital tones that are transmitted through the radio using a sound card interface. Messages are broken into small data frames and transmitted during synchronized time intervals. Unlike voice, the receiving station reconstructs the original text message from these digital frames. A major feature of JS8 call is directed messaging. Instead of broadcasting every transmission to everyone, operators can direct messages to a specific call sign. The program automatically manages acknowledgments and delivery status, making communication far more efficient than many traditional digital modes. JS8 Call includes an inbox feature that allows stations to leave messages for operators who may currently be offline. Once that station returns to the air, the message can automatically be delivered. This store and forward capability is one reason JS8 Call is often compared to an HF email system that requires no internet. Perhaps one of the most impressive features is message relay. If two stations cannot hear each other directly, a third station can automatically relay messages between them. This greatly extends communication range and allows messages to travel through multiple stations across an HF network. JS8 Call supports group messaging. Instead of sending messages to one operator, messages can be addressed to an entire group. This is especially useful for emergency response organizations, operating groups, preparedness communities, or clubs, coordinating activities across large geographic areas. The software offers multiple operating speeds. Slower modes provide greater sensitivity and work better under poor conditions. Faster modes increase typing speed when band conditions are favorable. Operators can choose the speed that best matches current propagation. The program supports CAT control for radios, automatic logging, APRS integration, PSK reporter, GPS grid exchange, and interfaces with numerous logging applications. To summarize, JS8 Call transforms the highly efficient FT8 protocol into a complete HF messaging system. With directed messaging, message relay, inbox storage, heartbeat networking, and excellent weak signal performance, JS8 Call has become one of the most capable digital communication tools available to amateur radio operators. Let's finish our discussion on the CDM primary modes of operation by reviewing ComStat and the advantages it brings to the CDM net system. ComStat is a software application developed to organize, monitor, and manage amateur radio emergency communications. It provides CDM operators with a centralized way to track resources, frequencies, personnel, and operational status throughout an incident. In the CDM system, the primary purpose of ComStat is to improve situational awareness. Instead of relying on handwritten logs or multiple spreadsheets, ComStat brings important operational information together graphically into one location. One of the strengths of ComStat is its ability to present operational information in an easy-to-read dashboard and on several different sizes of map displays. It also integrates seamlessly with JS8 Call to provide a powerful communication suite able to immediately call upon JS8's functionality with user commands directly from the dashboard. Depending on the configuration, operators should be able to view the precise locations of other CDM operators and groups, active incidents at the local, community, and regional level, frequencies where the other operators were last seen, current operational status reports, a macro view of communication resources availability regionally, nationally, and internationally. Other features include the ability to transmit up-to-the-minute status reports over the air and over the internet simultaneously or separately as the situation requires. This adds redundancy to the system and negates the need for any internet service to be available at all. The filtering system allows monitoring any active group of the operator's choice, and when the internet is available, provides for numerous overlays showing weather maps and radar, power outages, earthquakes, and wildfires, all while displaying the grid location of each operator reporting into the system. To summarize, ComStat is a communications tool designed to help amateur radio emergency communication teams organize personnel, equipment, frequencies, and operational information. When used effectively, it becomes an important part of maintaining good situational awareness and efficiently organized emergency communications within the CDM net system. Now let's put everything together and look at how the CDM network actually works. The process begins when a member of the public in a disaster-affected area needs to send a welfare message to family or friends outside the disaster zone. A community disaster messenger receives that information and prepares the message using the appropriate digital communication software. If internet connectivity is available through Starlink or another working connection, the message is transmitted using WinLink through the Common Message Servers, or CMS. From there, it is routed through the WinLink system onto the internet and delivered to its intended recipient. If Starlink is not available, the message is transmitted over the air via HF Skywave communications to an available RMS gateway station, which forwards it into the WinLink CMS system and onto the internet for delivery to the intended recipient. If internet access is unavailable, the message follows an alternate path. It is transmitted by HF radio in the hybrid system to another community disaster messenger station outside the affected area. That station acts as a relay, forwarding the message through available hybrid RMS stations, message pickup stations, peer-to-peer connections, or post office stations, until it reaches the internet email system or another delivery point such as telephone. Throughout this process, every station performs a specific role. Some stations originate messages, others relay traffic, and still others serve as gateways that connect the disaster area with unaffected communication systems. The important point is that the message is not dependent on a single route. If one pathway becomes unavailable, the network is designed to use another. This layered, redundant approach allows public welfare messages to continue moving even when portions of the communications infrastructure have been damaged or completely lost. The end result is simple but powerful, helping people reconnect with loved ones during disasters by using a resilient communications network built and operated by trained amateur radio volunteers. We hope you have found the information presented in this overview of the Community Disaster Messenger Network interesting, informative, and useful. We thank you for your attention, and we invite you to view Part 2 of the presentation, which concerns our alternate modes of operation, should they ever become necessary in a disaster situation. In addition, please visit our website at www.communitydisastermessenger.net for further information concerning the program. Also, you may contact us by email at community.disaster.messenger@gmail.com. Thank you for your continued support of amateur radio and your interest in supporting your community and the public should disaster ever strike. It's through the knowledge, teamwork, and dedication of volunteers like you that makes programs such as this effective in delivering the message for the public when it matters most.